Good afternoon, and once again, thank you so much for coming to SUSECon, but especially thank you for coming to my session. It's going to be full of slides. I'm just kidding, it's going to be a couple of slides, then it's mainly going to be more of walking you through the processes of NeuVector, what it is, what it's all about, and all of that great stuff. But if at any point, if you do have any questions at all, feel free to put your hand up, or we can have a Q&A towards the end of the session as well. So, one of my couple of slides is the agenda slide. So, I'm just going to start off with explaining of what NeuVector is. I'm pretty sure some of you might have heard of it, came to the booth or a couple of the announcements, but just going to start off by going through what NeuVector is, looking at how NeuVector can secure your supply chains. So before your images get into your production environments or before your images get into your runtime environments, how can you secure it? How can you make sure it's as secure as you can make it? But once it's in the runtime, how do you secure it further? Since securing the image is only part of the problem. Since Kubernetes is a dynamic environment, stuff gets spun up really quickly, spun down. It's ephemeral by nature. They have their own life cycle. So how do you make sure it's secure when it's running? And at the end, zero trust. So you probably heard probably zero trust mentioned quite a lot of the time. You probably all wondering, hey, that's a buzzword, right? But how does zero trust allow you to make sure when it comes to Kubernetes, you have the best approach for not attacking, but defending against the unknown attacks? So it's great, having that vulnerability management piece, knowing the CVEs, but what happens when it comes to the unknown attacks? So what is NeuVector? NeuVector is SUSE's container security solution. So it provides you with that end-to-end container security. So as I mentioned earlier, throughout your entire software development lifecycle, so all the way through your supply chain, so through your pipeline, through your container registries, all the way into actually your runtime environment. And that's really what makes NeuVector unique. So I'm pretty sure a lot of you in the audience might have used some sort of scanner tools out there in the market. You might have actually scanned those images before you put them into your runtime environment. But what actually happens in the runtime? And that's what really makes NeuVector unique. Since we're able to automatically learn the behavior of your applications, your nodes, your clusters. So how does it work on a day-to-day basis? After that, we're able to automatically create or generate security policies for that behavior. So you're not protecting your application, but you're tailoring your security policies towards your application, so it's not just generic. And again, we can do this at layer 7, so we're able to identify and validate layer 7 protocols. And out of the box, NeuVector has automatic detection for 23 network attacks straight away without you having to configure anything. So we're able to block it, packet capture it, ready for further analysis or for blocking. And again, we're able to do that deep packet inspection inside of a Kubernetes cluster. You might be thinking, great, again a buzzword, but what does it mean? It essentially means we're able to look at the live network traffic. So rather than being reactive when it comes to your security, you're able to be more proactive. So rather than waiting for something to happen, then say, that shouldn't have happened, let me try and block it, we're able to block it even before it happens. And again, work in air-gapped environments, we deploy as containers. So it doesn't matter what sort of Kubernetes cluster that you have. So it could be a Kubernetes distribution from SUSE, like RKE, K3S, or it could be any other CNCF certified Kubernetes distribution. But since we deploy as containers, we are really close to those workloads that you're running within your Kubernetes cluster, so we're able to have better visibility of them. And that's another key feature that NeuVector provides, that visibility of your east to west traffic, so that container-to-container traffic. So how does one container talk to some other container? What protocols are they using? How often are they communicating? Should they be communicating? And we're able to graphically show you all that sort of dependency of how everything's mapped together. Then when it comes to the supply chain side, we can do the entire scanning piece from your pipeline, your platform, your registries, be it public, be it private, your node itself that's hosting your Kubernetes clusters. But also we can check and report for compliance. So we check against the CIS benchmarks for security, but also we can report on things such as GDPR, PCI, HIPAA, NIST, etc. As well as mission control. So once you've gone through the stage of scanning your registry, scanning your pipeline, what do you do with that image, right? It might be safe now, it might not be safe tomorrow, so you need to continuously scan. But when it comes to actually deploying that image, we can have more of a guardrails into your runtime environment. So saying what's allowed and what's not allowed into your runtime environment. That's what essentially a mission control is there to do, to prevent unauthorized or vulnerable images from being deployed. And there's a lot of text on the slide, but I'll show you all of this in the actual NeuVector solution itself. So first of all, let's start off with when the image gets created. How does NeuVector do it? So when it comes to pipelines, so it could be Jenkins, it could be Azure DevOps, GitLab. We have a plugin for NeuVector into these pipeline tools. So as part of your build phase scanning, we can actually scan that container image before it gets pushed into your container registry. So pushing vulnerable images into that container registry. So again, this is a very quick example of how it might look. So as you can see, I've run a couple of builds in the past. So it's just a very simple plugin. Within Jenkins, you can essentially type in NeuVector plugin, and what it will do is it's building that image, and before you upload that image into your public or private registry, it's scanning that in order to say, is it allowed to pass? Is it allowed to fail? If it fails, it doesn't push it into that registry. What happens when something fails is you get a report to say, why did it fail, but also what sort of vulnerabilities exist within that actual image, right? Again, this is a very starting stage of your container journey, right, before it comes to production, but it's very important to make sure you're putting in CVE-free or vulnerability-free images as much as possible. It can be impossible sometimes to get to near zero, but it's always useful to know what CVEs exist or vulnerabilities exist within those images that you're creating. So the next step, you push that image into your registry. So this, as I mentioned, this could be public, this could be private, but once it's in those registries, it's very important to scan them in regular intervals. I mean, you can decide what those intervals might be, but again, as I mentioned, what's safe today might not be safe tomorrow. So as part of NeuVector, what we can do is, if I go into here, is we can link it to your container registries. So it's simple as, I'm hoping you can all see that. I'm going to zoom in a bit more. Put that down. There we go. You can add a registry. So from the drop down, it's very easy. You can say, what sort of registry is it? Is it a Docker registry? Is it one of the cloud hosted ones? GitLab. There's a whole bunch of them you can choose from. And you can say, what's the URL and what do you want to scan? So do you want to scan a particular image, your entire repository, and do you want to do layered scanning? So it's great, if NeuVector tells you it's got 10 vulnerabilities, it's 10 high vulnerabilities, well, what do you do with it? But instead of saying that, we're able to actually go into that image and do layered scanning. So if I were to take this one, for example, you can see 18 high vulnerabilities, 16 medium ones, but where are they coming from within the particular Docker file? So you can go ahead and look at what's actually happening within the image and see what version are you using, what's the fixed version, when was it published, and you're able to get more information about that particular CVE. And the same thing for compliance. So as I mentioned, we check against the CIS benchmarks for security. So this is checking against the image compliance violations that might exist. And the same thing for the top riskiest modules that you have within that particular image. So this is all, again, really great, but what do you do with it? So cool thing you can do with this is link it to a mission control. So as part of this, you can add in rules in order to prevent, as I mentioned, unauthorized or vulnerable images from being deployed. So you can essentially say, pick from the whole bunch of criteria that is there, saying if there's a count of high severity, based on CVE names, if an image has been scanned, or if there's an environmental variable that's present within the image, or is it going to a particular namespace? Is it coming from a trusted registry? As I mentioned, there's a whole bunch of things that you can choose from. But if I were to give you a very basic command, it might be the case of, if an image has not been scanned, deny that deployment, right? Again, it's a very simple rule, I know, but just to showcase, one, what it is, how it works. So I think I already added it in, so got it here. So image scanned equals false. It's in monitor. So we have different modes within NeuVector. So we have discover mode, which is for learning the behavior of the application. We have monitor mode, which is for alerting you on any sort of anomalous behavior or unknown behavior. Then we have protect mode, which is for blocking any sort of unknown or anomalous behavior. So what I'm going to do here is just straight away move it into protect mode. Click OK. There we are. So what I'm going to try and do is into my deployment. Hopefully you can all see that. Sorry. And try and deploy my most JApp. I'm going to go and deploy my most mission critical application of Super Mario. Again, I have not scanned it, so it should block it according to that mission control. So if I click create, as you can see at the top, it says creation of Kubernetes deployment is denied because of the mission control webhook. And even though I showcased a very basic command, there's a whole bunch of criteria you can choose from. It can be absolutely really complex. You can look for custom criteria, but it's very important to make sure you know what you're deploying into that runtime environment. And once it's in the actual runtime environment, what we can do is, again, from a scanning perspective, we can check through your platform. So what Kubernetes distribution that you're using, your actual node, so you're running nodes within your Kubernetes cluster. Again, checking for compliance, as well as for vulnerability, so what CVEs exist, what severity, what version, what fixed version, but also you can click there and get more information about it if you do want to. And again, I can do the same thing for containers. So you're going through the whole stack rather than just scanning the running container. So again, I do have, I believe, my WordPress application here. Again, I can check for one, the compliance, two, the vulnerabilities, to make sure what's actually happening in my environment from a vulnerability standpoint. But a cool thing I can also do is gather all that information into my vulnerabilities tab. Then you can see, hey, this particular vulnerability, is it impacting my image, my running container, my node, is it impacting my cluster? And then you're able to take more actions in order to say, I'm fine with this vulnerability, it does not affect my Kubernetes environment. Or you can go ahead and filter this down to say, give me everything with a fix that has a high severity rating. So you can sort of prioritize where you start fixing this or going back and reviewing these CVEs and if they're going to affect your environment. And as with everything with NeuVector, you can obviously get a view in terms of a compliance view or a vulnerability view to say, hey, give me a report based on this, and hope you can all see that. But yeah, it just gives you a very nice report in order to pass over to anyone that you want. Same thing with compliance. So again, I know this is a sort of an important topic when it comes to compliance, and it can be quite tricky. So again, we do the same thing from a compliance perspective of making sure we give you all of the compliance violations that exist within your Kubernetes cluster and the impact of them. So from here you can see this particular violation is affecting my 2 containers, including my WordPress one, or is it affecting my image, my node, etc. But key thing here is, again, I can filter this down. So if I come to any of you and say, can I get a report on GDPR for this particular Kubernetes cluster or your particular namespace, you can quickly go in here and say, sure, why not? Click GDPR, click apply, filters that down, and you're able to, again, get a very nice view for that compliance report. And again, you can pass it over to whoever's responsible for handling that piece. And if you're just wondering, here is the entire compliance checking list. Also, you can run custom checks as well if you do want to, if you are running a particular compliance standard or regulation that you want to check against. But these are all the CIS benchmark items that we check against. So that's everything from that sort of supply chain side to make sure, when it comes into, or before it enters into your runtime, how do you protect it? But when it comes into the actual running containers, those running images, how do you protect it? So what NeuVector does is automatically create groups from your running containers. So everything that you see there with the prefix of nv dot is the automatically created groups. Obviously, you can create your own groups. So if you want to say, give me every container based on this namespace, and you can create a group like that. Since containers spin up and down very constantly, it's quite hard to address them directly. So you can use something like groups to have that level of abstraction in order to apply your security policies. So anything that's part of this group will inherit that security policy. So again, good old Blue Peter style. I do have a application deployed already. So my WordPress application, again, it's very basic application, nothing special. I can actually show it to you. If that loads up. Oh, well, give me a second. Do we have any questions at all so far? No? Okay, perfect. I think my internet probably just cut out, so just give me 1 second. It's all part of the live demo experience, this is, so just give me 1 second. There we go. It's all back up again. So let me just refresh that. So yeah, as I was saying, it's just a very generic WordPress application, so nothing special. It's just hello world. If I click on there, no sort of commands, nothing like that exists. So if I want to say, Susa is amazing, right? Give my name. That's a fake email address, so if you try to ping it, it won't come up with anything. That post, just to make sure I'm not, doing any sort of magic behind the scene. But essentially, I have my WordPress application in protect mode. As I mentioned, we have 3 different modes within NeuVector. So discovery for learning behavior, monitor for alerting, protect for blocking that sort of anomalous behavior. So what NeuVector will automatically do is learn the behavior of your application. So as I mentioned earlier, it's able to automatically learn the process, the network, as well as the file access behaviors. So as you can see here, as part of my WordPress application, as part of me running on a day-to-day basis, these are the sort of processes that's learned automatically. And again, as you can see by the type here, it's all learned. I haven't user created it. And essentially what this will do now is, if I put it into monitor mode, is use this as a baseline or a rule set to say, anything outside of these processes, alert me. Or if you put it into protect mode, anything outside of these processes, block it. So if someone does, shell into your container and tries to run any sort of commands, unless you allowed it, it does not happen. And again, it's all well me saying it, so let's actually try it out. So if I do a quick ls, just to make sure that does not exist in there. Go into my deployments, execute shell, there we go. So the only thing I did is just shell into my WordPress application. If I just do a quick ls, as you can see, operation not permitted. Or if I do something like, make directory test, it could be anything, right? So again, these are just simple commands, but just to showcase the point of we're able to identify it, we're able to block it, and we're able to alert you on any sort of anomalous behavior. So if I go into security events, you can see process profile rule violation by ls, make directory, etc. But we can do the same thing for the network rules. So these are saying what network connection should be allowed as part of my normal behavior. Right, I can talk to my WordPress DB, that's fine over MySQL, it can reach externally, that's all great. But again, anything outside of this, I want to restrict it, tune it down, block it, or alert it based on what I wanted to do. So again, I can review this rule, then I can go ahead and say, you know what, again, I know you probably won't do this, but you know what, I don't want my WordPress to talk to my WordPress DB. So I can go ahead and say that network rule there, I don't want it existing. Click OK, click Save. And if I go into groups, and I'm going to move them into protect mode. So now it's seen that again, these are the network rules which are allowed. So I can reach externally, all of that stuff. But again, if I were to do the same thing of making the comment again to say, J is all right. So, syntax. There you go. Try to comment that. As you can see, it's trying to connect to the database over MySQL, but you can't, since that's not a learned behavior. Again, you might not probably do this in production, but just to showcase the example of, one, we can learn the behavior of your application. Two, we can create that zero trust segmentation around your application, around the known behavior. Anything outside of it, process, network rules, file access behavior, we can block, alert, packet capture, all of that great stuff. And again, key thing with this one is if I do want to, I can go ahead and add a rule in. So if I want to, for example, say, add a rule, I'm happy for ls to work, deploy, and if I scroll down, if I refresh it, you can see ls is user created. So you can sort of fine tune it depending on what your environment is. But as I showcased earlier, we just did it on a per container level. You can do this at a namespace level, so everything under a namespace gets that sort of same security posture or security rules. But again, NeuVector does a lot of the legwork for you, so you're not starting from scratch trying to define what's allowed, what's not allowed, etc. A key thing also here is you can export these policies. So if you want to export this, you're able to export this across. Do you want to export as default, so whatever mode it's in right now, so protect mode. Do you want to export that in discover, monitor, or protect? So what you can do is, say, imagine you are testing out your application, you are deploying a new service, and you deploy that into your test environment or dev environment. And what you can do there is have NeuVector running in monitor or discover mode. And then when you're happy with all of the discovery work is done, all of the alerts is showing up, and when it comes to your actual production environment, you can export this policy in protect mode. Let me just allow. And when it comes to your production environment, as soon as you deploy that application, you can deploy or import that security policy that we just exported. And essentially, it's a YAML file. So you can even use something like GitHub's approach to essentially deploy these security policies across other clusters running the same application. So just to showcase, it's just a simple YAML file, and you can see all of that. MySQL, it's allow. You can see all of the connections, like probably see ls in there somewhere. Ls, allow. It's all of the information that I've fed it or created or configured, but in this YAML file. So you're able to import that and make sure whatever environment that you have your clusters on has the same zero trust segmentation, zero trust controls. And it doesn't matter if a new application is spinning up, spinning down, we have our list of allowed rules, allowed policies. So anything outside of that, it does not matter. And that's why I said zero trust is very important, since it doesn't matter how dynamic it is, we know what's allowed. And anything outside of that, you can allow it manually, but it gets blocked by default. Another key thing is response rules. So it's great something gets blocked or alerted, but what should happen afterwards? What happens, say, if something gets blocked? Should you be alerted? Should the container be quarantined? And again, quarantining is very important when it comes to Kubernetes. As I mentioned before, Kubernetes has some self-healing capability. So if it's part of a deployment object and you try to kill a pod, you might try and spin back up, and you're back to square one with that vulnerability. In this scenario, you're blocking traffic. So you're blocking the inbound, outbound traffic, northwest traffic. That means you have time to, one, identify what the issue is, solve it, and probably redeploy the pod again. So for example, I can say what sort of event it is. Is it a security event? Is it a generic event, CVE report, a mission control violation, but I'm going to keep it security. I'm going to say, WordPress application. Oh. There we go. Criteria, so I'm going to say process violation. And what I wanted to do, so do you want it to alert me over a webhook, so Slack, Teams, etc. Or you're testing it out, there's going to be an error, do you just want to suppress the log, or quarantine the container? I'm going to select quarantine because I think it's much more cooler to show you during the session today, so I'm going to click add. That's added. So if I go ahead and go into the shell terminal again and try and run the command, again, it's not permitted. If I type in ls, it should allow me to do it because I added it in earlier on. But if I go into my group my WordPress application members, you can see that application has been quarantined. So again, it's very important to make sure we're not killing off those containers as soon as you see a vulnerability pop up. We're actually quarantining it, allowing you to have more time to remediate what the actual issue is. Again, as part of NeuVector, we have key things such as DOP sensors. So since we can do the deep packet inspection inside of a Kubernetes cluster, we can sort of identify that sort of container-to-container traffic. And since we can do that, we can check the traffic for any sort of sensitive data. So it could be credit card information, financial data, personal identifier information. Essentially what we do is we have regular expression or regex, and essentially we look for patterns within the network. So by default, it's predefined. We have credit card information, social security numbers, and you have all of that sort of patterns over here. And we can do the same thing with WAF sensors, so the inbound, outbound traffic, so things for Log4Shell, Spring4Shell, all of that great stuff. And again, depending on the criticality of your applications, you can do this at any sort of level. So you can do it on a group level, so container level based on the group, namespace, etc., whole cluster. So again, it provides you the ability not to just do that CVE management or vulnerability management, but actually protecting your runtime environment against the unknown threats. And also a key thing here is visibility. So I think I made this point earlier of if I were to ask any of you, how does one container talk to some other container within your network? You might be able to find that in 10, 15 minutes, but with NeuVector, you're able to get that with the click of a button. Right. So if I click on network activity, let me speed this up. You can see, I'm going to put this out because of the internet. It does not like to play. There we go. I know this is a boring process for you, but that's why it is based on the internet. I'm just hotspotting off my phone right now. So it just shows you, hey, how is one container talking to some other container? What protocols are they using? Is it HTTP? There we go. Is it HTTP, MySQL? All of that scenarios that we come across before. But should they be talking to each other? That's the main question, right? Since you deploy an application within Kubernetes, you just let it run, and it's quite mysterious in the way it runs. So this just allows you to bring it back, see what's actually running. You're able to get rid of that sort of container sprawl scenario where you're not running applications or running containers that you're not aware of. And what are they communicating? What dependencies are they? And from here, you're able to see, do you want to start a packet capture? Do you want to move this into monitor or protect mode? Do you want to get more details? How much data is being transferred? So you have all of that amazing capability straight from here. So you're able to visualize how your environment is looking from a network connection perspective. And the last thing here is security events. So it's great. It's able to block it, do all of that stuff. But what happens when there is a security event? It's able to, one, as I mentioned, ping you or alert you using a webhook, but also for those critical sort of attacks like OWASP top 10, something like SQL injection, it's able to automatically detect it, block it, as well as packet capture. So if I scroll down here, try and see if there's, there we go. Again, these are stuff that you don't have to configure yourself. NeuVector automatically detects them and blocks them. So again, if you have no background in security, or if you have no background in how to run NeuVector, out of the box, it has a couple of these security controls ready to go. So if I were to show you a couple of the... There you go. As you can see here, that's an automated packet capture when threat is detected. And again, it's able to give you the PCAP file for essentially for the forensic use something like Wireshark to essentially analyze it further. But again, it gives you the capability straight away from the same UI, from the same platform, to do all of that, all the way from scanning through the environment, you're running containers, to make sure you know what's actually happening in your environment. You know what processes, what network rules, and you're able to create that zero trust segmentation to make sure what's allowed is allowed. Anything outside of that, you get alerted, blocked, etc. Probably the last and final thing I'll probably showcase on this scenario is, say if you have a multi-cluster environment, you're able to have a NeuVector federation, which means you're able to have multiple new vectors feeding into one, essentially allowing you to have a federated policy or to set up golden policies, especially when it comes to admission control for scanning those registries, etc. So if I were to say in a federated policy, got like 4 clusters underneath it, I'm able to say admission control, these are by default, all of those clusters will inherit this policy. In this case, admission control, to say if the namespace, if you're trying to deploy into the default namespace, deny it. If the image hasn't been scanned, deny it, etc. So you can set up these golden policies across your organization, across your Kubernetes environments to say, these are my base level standards. Same thing for network rules. Again, network rules and process rules are quite dependent on the application or quite dependent on the group. So you might not have loads of these for that sort of a federated policy, but a couple of these might be useful, especially when you're setting up those policies for the node groups or node levels. Same thing for file access, response rules, webhooks, etc. And again, you can cycle through all of these to make sure you have a very easy to use UI, but also if you do want to use APIs, again, everything that you see here is being delivered via API call, so you can essentially use the APIs as well for NeuVector. So coming back onto probably one of the last slides here. I guess just to summarize, NeuVector is our container security platform solution for securing your containers from your development environment to your production environment. And it doesn't matter, what Kubernetes distribution that you use. You can use, something from SUSE, something from any other vendor. NeuVector is able to very easily protect your containers, especially in their runtime, from unknown and known attacks. So from a compliance management perspective, we can scan through the pipeline, we can scan through the registries, as well as the container runtime. And again, we're able to do the vulnerability scanning as well as compliance scanning to make sure if someone comes along and asks you for a report, with the click of a button, you're able to give that report straight away. And when it comes to the runtime security, we have admission control to prevent any sort of unauthorized or vulnerable images from being deployed into that runtime environment. And also, we're able to have that layer 7 visibility, so stopping traffic as early as possible, stopping attacks as early as possible. And we give you back that visibility into your Kubernetes cluster, so you're not guessing what containers are running, how they're connected, what protocols are they using, etc. And with the inclusion of DLP and WAF sensors, you're really fine-tuning your security for protecting against that sort of sensitive data, private data, etc. And lastly, zero trust. Right, since we know how your application behaves, we're creating that zero trust segmentation. So it's not generic policies, it's fully automated. As you saw, it's fully learned. You can add it manually, but you have a complete list of your allowed rules, behaviors, policies. So anything outside of that, it's blocked. So it's very accurate, and there isn't any sort of ways to get around it. And the key thing here is you can have everything as policy as code. So once you set it up, you can export it, you can import it into other clusters, so you're able to replicate your zero trust segmentation, so making it very easy for you to achieve your security across your multi-cluster environment, be it on-prem, cloud, edge, etc. And if you're wondering, is it easy to deploy NeuVector? Absolutely. So, there's multiple ways to deploy it, but we have a Helm chart, I'll probably say probably easy. It deploys as containers, so we don't use any sort of agents or sidecars. It fully deploys as 4 containers. Essentially, we have a controller container, acts as a control center for the system, the brains of the operation. We have the scanner, which is responsible for scanning the environment, and also the CVE database is contained within the scanner container itself. So there's no sort of overhead when scanning, and it doesn't really call home or anything like that. Then we have the manager, which runs the web UI, which I showed you earlier, handles all the API calls. But also we have the enforcer, which gets deployed as a daemon set across all of your nodes, and that's the one that's responsible for inspecting the traffic as well as enforcing those security policies. And yeah, as I mentioned, it's very easy to deploy, so if you do want to give it a try, absolutely, feel free. With everything that SUSE does, it's completely open source, so it's fully documented, NeuVector docs, so you can go ahead, tells you all of the great information of what it does, how to deploy it, a couple of the popular topics, and essentially give it a try and come back to me or come back to anyone within SUSE. Be more than happy to help you throughout that journey. But I'll probably say I'm Jay Joseph, Solution Architect. And thank you for coming to that session today. I hope you enjoyed it, loved it, and give it a try.